Hello and welcome to our Cisco DNA Center training series. My name is Doug Nguyen and I'm a technical marketing engineer working on Cisco DNA Center. Cisco DNA Center is our premier network management product that brings innovation and simplicity to managing your networks at scale. In this video, I will give an overview of Cisco DNA Center's application visibility feature. Application visibility is a component of the broader application experience suite. So what is application experience, also known as AppX? AppX encompasses three main components. The first is application visibility. App visibility forms the foundation of AppX and is responsible for identifying applications on the network and to report the usage and performance to DNA Center. Application visibility is the focus of this video. The second component of AppX is application policy. This component is about controlling application network resource usage by defining and applying QoS policies. The last of the three components is application assurance. This component entails analyzing the telemetry data and presenting it in a meaningful way that allows users to measure and validate application performance and health. So, how does application visibility work? Let's start with this diagram to understand the pieces of the puzzle and how they fit together. At the bottom of the diagram are the network devices that transport network traffic. When telemetry is enabled on these devices, they will inspect the traffic and send information on the traffic to a collector. In this case, the collector is DNAC. To identify and label the applications, the devices use NBAR2, which stands for Network-Based Application Recognition version 2. It is the mechanism used by some of our network devices to recognize applications by inspecting some packets in the flow and applying deep packet inspections and other techniques. For wired networks, the devices that use NBAR2 are the switches and routers. For wireless networks, the work is done by the AP, who will then send the telemetry onward to the wireless LAN controller, or WLC for short. In order for NBAR2 to recognize applications, it relies on the signature information contained in the protocol packs. There are two protocol packs in each device, a primary and a secondary. The primary protocol pack is a static protocol pack that is installed on the device as part of the OS. It contains the bulk of the signatures, about 1,400. The secondary protocol pack is a dynamic protocol pack that is updated as needed with new or updated application signatures. Now that the application has been identified and classified, this information can be added to the telemetry and sent to DNAC. There are three ways in which DNAC can receive application telemetry data. One is via NetFlow, or NetFlow with APM, which stands for Application Performance Monitoring, and lastly, streaming telemetry. So NetFlow is a networking protocol developed by Cisco for collecting IP traffic information by examining the flows of data as it enters and exits an interface. These flows provide quantitative metrics on the application, such as usage and throughput. NetFlow with APM is essentially a NetFlow with additional application performance monitoring capabilities, such as media monitoring and ART, or application response time. In addition to quantitative metrics, it can provide qualitative data of application performance, such as packet loss, jitter, and latency. Note that APM only applies to TCP and RTP traffic. The third way is with streaming telemetry. Streaming telemetry is a mechanism to efficiently stream data of interest to remote management and monitoring station. It is based on a pub-sub model. The method used to send telemetry depends on the type of network device. Note that the older AROS WLCs use streaming telemetry, while all other network devices use NetFlow or NetFlow with APM. Cat9 switches and AROS WLCs do not support APM. As a result, they can only provide quantitative application metrics of usage and throughput. Routers, traffic telemetry appliances, or TTA for short, and iOS XE WLC supports APM and can provide additional qualitative metrics on top of the quantitative metrics. As DNAC receives these application telemetry data, it will analyze them to present on the dashboards and widgets. Application metrics can be viewed from multiple dashboards. There is an overall health dashboard per building with summary data. Additionally, you can drill down to per application with Application 360 page, or per device with a Device 360 page, or per client with a Client 360 dashboard. A key piece of application visibility is CBAR, which stands for Controller-Based Application Recognition. CBAR is a service that runs on DNAC. It provides centralized management of the protocol packs on the network devices. CBAR is responsible for a set of tasks. One is managing the primary protocol packs on the network devices. With CBAR, these protocol packs can be updated to the most current version. CBAR also provides a mechanism to recognize custom applications with the input of user definitions. In addition, as CBAR receives application signature updates from cloud sources, it will dynamically push these updates down to the devices. In doing all these tasks, it improves application recognition by NBAR2. When enabling application visibility on DNAC, there are two algorithms that are available to let DNAC know which interface to enable telemetry. One is the conventional method, where the user manually selects where to enable telemetry by tagging the description field of the interface or SSID with the word LAN. Some users may want to manually select interfaces for specific reasons. An easier way is with the automatic algorithm. DNAC will automatically select interfaces to enable based on a set of selection algorithm outlined in the chart. If a different selection is desired, the user can use the conventional method for that device. Note that once DNAC sees the LAN keyword on any interface or SSID for a device, DNAC will not use the automatic algorithm for that device and will revert to the conventional algorithm. For automatic algorithm to work properly, ensure that connected devices have CDP enabled. For more details, see the link to the user guide in the description below. Once application visibility is enabled, applications are categorized into 3 classifications by default. These classifications are business relevant, default, and business irrelevant, and are based on industry best practices. For application policy, this classification determines how traffic are prioritized and policed. For application visibility, it affects how the applications are displayed on the dashboards. These default settings are customizable by editing the properties of the application. How to enable application visibility. First, ensure that under software management that the required software packages, application registry and application visibility service are installed by checking the software management page of your DNAC. On DNAC, enable NetFlow and wireless telemetry. This will start services to DNAC to accept NetFlow and streaming telemetry. Device provisioning will now know to use DNAC's IP as a destination for NetFlow and streaming telemetry. The next 2 steps are not required but recommended. The first time that this page is viewed, a prompt will ask if the user would like to enable CBAR. Select yes. This enables the CBAR service on DNAC. With CBAR enabled, the next step is to configure the cloud integration with NBAR Cloud, MSO 365, and InfoBlocks. Once complete, the cloud integration can provide additional and updated signatures to CBAR. Step 4 is to register your devices to use CBAR. Select the devices that you will configure telemetry and enable CBAR for that device. This will push configuration to the device to send information to CBAR and allows CBAR to manage the protocol packs for that device. The last step is to select the desired devices and enable telemetry. This step pushes configuration to turn on NetFlow or streaming telemetry and NBAR 2 on that device. At this point, you can start viewing application telemetry on your dashboards. This completes the video on application visibility overview. Thanks for watching, and remember to see the description section for additional resources and information.